Welcome back to the deep dive. We grab the sources, cut through the noise, and give you what you really need to know. And today, we're doing something really specific. A deep dive aimed squarely at anyone facing their ATPL theory exams. Or, honestly, anyone curious about a key piece of aviation tech. The aircraft propeller. We've looked at techs like propellers, aerodynamics, efficiency, and control, plus a lot more to get you the clearest picture. Okay, so let's get into this. The plan isn't just to list facts. No, we want to cut through the complexity. We want to show you the why behind the what, give you those real aha moments, so you can confidently handle any propeller question they throw at you. From the basics to those tricky left-turning tendencies, we're aiming to make it all make sense.
Exactly. And for you aspiring pilots, this stuff isn't just, academic theory. It's absolutely fundamental. Understanding how your aircraft behaves, the forces involved,
Right.
how to get the best performance. So our mission today, distill the critical knowledge, really emphasize the key concepts. Make sure you get not just what happens, but why it happens, because that's what the ATPL exams test, that deeper understanding. Think of this as your fast track to really mastering propellers.
Okay, so let's start right at square one. You see that prop spinning. What's its actual job? What's it doing?
Well, at its absolute core, a propeller is this amazing bit of engineering. Its job is to take the rotational power from the engine shaft and convert it into useful forward thrust.
It's like a very powerful fan, essentially.
Sort of, yeah, but incredibly efficient. It works by grabbing a huge mass of air, scooping it up, basically, and then accelerating that air backwards really powerfully. And the physics is pure Newton's third law, action and reaction.
Equal and opposite.
Exactly. That strong rearward push of air creates an equally strong forward push on the aircraft. That's thrust. That's what makes prop planes fly.
Simple concept, but I bet the details get complicated fast. And for anyone studying for ATPLs, getting those details, those precise definitions, right, is absolutely key. You said the blades are like wings, aerofoils, but they have their own special terms, right? Let's nail down that essential geometry.
Absolutely foundational. First up, blade angle, or often just called pitch. Imagine you slice through a blade, look at the cross-section, you see that wing shape, right? Leading edge, trailing edge. The blade angle is specifically the angle between the blade chord, that straight line from leading to trailing edge, and the plane of rotation.
The plane of rotation being
Yeah.
just the disc the prop spins in.
Exactly, the flat circle it sweeps out. So it's how much that little wing section is tilted relative to the direction it's spinning. This definition is critical. You'll see it in exams. Blade angle of a propeller is defined as the angle between the blade chord and the plane of rotation. Get that locked in. And here's something vital. That angle isn't the same all along the blade. It actually decreases as you go from the root near the hub out towards the tip.
So it twists.
Precisely. It's called twist. And there's a very, very important reason for it, which we'll get to. It's all about efficiency. But for reference, for measurements and calculations, the standard is to measure that blade angle at a specific point, 75% of the way out from the root.
Okay, 75% point. Got it.
That's the reference you need to know.
So we have blade angle or pitch,
Yeah.
but then you hear about geometric pitch and effective pitch.
Yeah.
And slip. How do they all relate? It sounds
Yeah.
confusing.
It can be, yeah, but let's clear it up. Geometric pitch first. This one's purely theoretical. Imagine the prop is like a perfect screw drilling into something solid, like wood. No give, no slippage. Geometric pitch is the theoretical distance that screw would move forward in one single complete revolution. It's based entirely on the blade angle.
So it's what the design intends it to do in a perfect world.
Exactly. Perfect world scenario. So remember this definition. The geometric pitch of a propeller is the theoretical distance the propeller would travel forward in one complete revolution if it were moving through the air at the blade angle. Theory.
But air isn't solid wood. It moves, it gives way.
Precisely. Air is fluid. Which brings us to effective pitch, sometimes called advance per revolution. This is the actual distance the propeller manages to move the aircraft forward in one revolution, in real flight conditions.
And this isn't fixed.
No, not at all. It's dynamic. Depends heavily on the aircraft's forward speed, its true airspeed.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.